Algebra 2, Concept 13, Classifying and Evaluating Polynomials. First, let's get down some vocabulary and definitions. So, we're going to talk a lot about polynomial functions. This is a function that is a monomial. You know, mono means one, so that means single term, or a sum of more than one monomial, or a sum of monomials. There's an example, and it's in function form. F of x equals negative 4x, so that's the first term, plus 2x to the fifth, that's the second term, minus 12. Here's another term we're going to talk a lot about this entire unit, the leading coefficient. So this is the constant that is multiplied by the largest exponent term in a polynomial. We're also going to talk about the degree, either of a term or a polynomial. And this is the largest exponent term of a function. So in our example up above, that is a degree 5 polynomial because the largest exponent is 5. And then finally, standard form. A polynomial is in standard form with its terms written in descending order of its exponents. So I gave you an example. F of x equals 3x cubed plus 2x minus 12. So notice the exponents are in descending order. We have third power, first power, and then technically that negative 12 is x to the 0 power. All right, let's back up a little bit. Whoop. So a polynomial function is a monomial or a sum of monomials. We just got that definition down. There are two conditions that must be met for a function to be a polynomial. The first condition is that the exponents are whole numbers. And remember, this is 0 and the counting numbers. So you can have a 0 exponent term. You won't see the term, but it will technically be the variable to the 0 power and then counting numbers, 1, 2, 3, 4, all positive. The second condition is that the coefficients are all real numbers. Now this includes a lot of strange numbers. It includes square root, it includes irrationals like pi, but what it doesn't include are imaginary numbers, ones with the I term. Now a couple other characteristics about polynomial functions. The largest exponent is the degree of that function. And then the polynomials in standard form if its terms are written in descending order of the exponents. But just to review, the two criteria for a function to be a polynomial are that the exponents are whole numbers and the coefficients are real numbers. Now let's classify some polynomials. So if you look at this table, you want to fill in the table in your notes. So the first way we can classify them is by degree, and then by the type that names the function, and then I've given some examples. I've written them in function form, f of x. You could also write them in equation form, y equals. So our first polynomial is degree 0, and it's a constant. So notice the example is f of x equals negative 14. You don't see a variable term because technically that term would be to the 0 power, which simplifies to 1. Then degree 1 is a linear function. You're very familiar with those. F of x equals 5x minus 7. Degree 2 is a quadratic. F of x equals 2x squared plus x minus 1. Degree 3 is a cubic. Our example is f of x equals x cubed minus x squared plus 3x. And notice all of these examples are in standard form. The exponent terms are in descending order. 4 is called a quartic. F of x equals x to the fourth plus 2x minus 1. That's our example. And then degree 5 is called a quintic. F of x equals 3x to the fifth plus x to the third minus 5. And those are all the polynomials we'll be dealing with in this unit. A polynomial with this many terms is classified as, so this is another way you can classify a polynomial. If it has one term, we call it a monomial. Mono means one. 2 terms, binomial. Bi is the word stem for 2. 3 terms, a trinomial. And then more than 3 terms, we simply call it a polynomial. Poly is the word stem that means many. All right, now let's look at Example 1. So we're going to look at each of these functions and decide if they are polynomials first. If it is a polynomial, we're going to write it in standard form, state its degree, its type, its leading coefficient, and then classify it by the number of terms. So if we look at A, f of x equals, now remember the two criteria. Do the exponents, are they whole numbers, and are the coefficients real numbers? So for exponents, I have 3, positive 1, and technically a 0. And those are all whole numbers. My coefficients are negative 2, 5, and 8. Those are all real numbers, so yes, A is a polynomial. And if I look at the exponent terms, they are in descending order, so it is in standard form. I don't need to rearrange this. I'm looking for the highest exponent to determine its degree, and that's 3. And then I look back on the chart, or remember that degree 3 is called a cubic. The leading coefficient is the constant that's in front of the biggest exponent term, so that's negative 2. And then finally, it has 3 terms, so this is a trinomial. Now, if we look at B, remember the two criteria are whole number exponents and real number coefficients. So our exponents are 2, negative 1. So I stop right there because negative 1 is not a whole number. So this means that this is not a polynomial, and then we are not going to move forward in classifying it. It is an equation that we could work with at some point, but just not in this unit. All right, example 2. It says evaluate by direct substitution. So we have this cubic polynomial f of x equals negative x to the third plus x squared minus 12x minus 5. And we want to find out what this equals when x equals 2. So we're going to plug in 2 everywhere we see an x. That's called direct substitution. So instead of f of x, we'll write f of 2 equals negative 3, and then in parentheses 2 to the third, plus in parentheses 2 squared, minus 12 in parentheses 2 minus 5. It's just a good technique whenever you're substituting in values to put them in parentheses. And then I'm working left to right, and so I'm going to cube my 2, which is 8. 8 times negative 3 is negative 24. 2 squared is 4. Negative 12 times 2 is negative 24 minus 5. And then if you work left to right, either by hand or on your calculator, you will see that f of 2 equals negative 49. And so we write it in that final notation so that we can see exactly what f of x equals when we plug in 2. F of 2 equals negative 49. Now, there's another way that we can evaluate polynomials for values, and this is a method called synthetic substitution. It's going to feel strange at first, but once you get the hang of it, I think you'll like it. So, step 1, you're going to write the coefficients of f of x in descending order of exponents. So, those coefficients are 2, negative 5, negative 4, and 8. But there's a really important point that if we have a missing exponent term, so in this case we have a missing x squared, we're going to put in a 0 placeholder for that term. And we're going to then put what we're evaluating this function for, in this case it's 3, to the left. So if you look in the space below, notice how I space out these coefficients. So I'm identifying them. So I'm going to place them in the space below 2 and leave some space, negative 5, and then 0, and negative 4, and 8. And then I'm going to use an upside down division, long division symbol, and just to the left outside I'm going to place the 3. Now the way this method works, so step 2, we're going to start by just bringing down the leading coefficient and placing it underneath the line. We're going to multiply that leading coefficient by the x value, 3. So we're multiplying diagonally and then writing the product under the next coefficient. So watch this. I'm going to bring down 2. I'm going to multiply it by 3 and place it underneath my next coefficient. Now I'm going to add vertically. So negative 5 plus 6 is 1. And then we're going to repeat the process, this time multiplying 1 by 3. Placing it underneath and adding. 0 plus 3 is 3. And then we do that process again, multiplying 3 times 3, which is 9. And then we'll add vertically and get negative 5, and then multiply diagonally. 3 times 5 is 15, and add vertically. So if we look at step 3, it says the final sum is the value of f of x at the given. So our final sum is 23. So we can write that f of 3 equals 23. And that's how synthetic substitution works. Now, do some independent practice. So pause the video, work numbers 1, 2, and 3, and then come back and check your work. All right, welcome back. So let's look at number 1. You are classifying, and so we have whole number exponents and real number coefficients. So yes, it's a polynomial. In standard form, you will have your x to the 4th term first, then x third, and then your constant. Its degree is the biggest exponent, which is 4, and that is a quartic. The leading coefficient is that constant in front of that 4th degree term, so that's the square root of 2, and it is a trinomial. Number 2, you should have classified that as not being a polynomial because x is not a whole number. Number 3, substituting by direct substitution. I'll just show you we're plugging in 4 everywhere we see an x. And then you can use your calculator, plug it in just as you see it if you like, or you can do it by hand, and so you should get g of 4 equals 9. Also evaluating this using direct substitution, we place our coefficients across our space. We're not missing any exponent terms. We place what we're evaluating the function for, which is 4, and then you bring down and multiply diagonally and then add vertically. 4 times negative 1 is negative 4. Add vertically. 4 times 2 is 8. 9. So also with this method, you can see that g of 4 equals 9. All right, that concludes the notes. You're ready to move on to the teacher talk.